so we've just got a handful more on this section. So the next one is going to be consider the following, and we have to find the actual formula for the tangent line. So if you'll remember, for the equation of a line, I need an x and a y coordinate, and then I also need the slope. Well, the derivative is the formula for slope at that point. Okay. So that being said, first of all, look at your pretty pictures, because only one of these is a tangent line. Okay. This slices through the graph, so that's not it. That slices through, that slices through. This is the only one that actually skids right up next to it and doesn't slice through. So that's going to be your answer as far as the graph goes. Plus, you own a graphing calculator. So second of all, if I want to find the derivative, so again, I'm using the point 1 comma 0. Oops, sorry, 1 comma 9. 1 comma 9. And then I've got y equals 9x squared minus the natural log of x. Okay, so I want to take a derivative. I've got my x, I've got my y, which is not prettily written. So the formula for slope will be the derivative of this. So that gives me an 18x minus what is the derivative of the natural log. It's the derivative of the argument over the argument itself. So that's my formula for slope. Well, at what point am I evaluating? I'm evaluating at 1. And so my slope is going to be 18 times 1 minus 1 over 1. So 18 minus 1 is 17. Okay, so now I've got an x and a y. So if I want the actual equation of the tangent line, I've got 9 equals a slope of 17 times an x of 1 plus b. So if I subtract 17 from both sides, that's going to give me a negative 8 equals b. So your final equation for your tangent line is y equals 17x minus 8. And that's the equation of the tangent line to this graph at the point 1 comma 9. All right, so the next couple are what happens if what we're trying to differentiate is really nasty ugly. So I've got what we can do is called logarithmic differentiation. So I've got y equals x times the square root of x squared plus 19. And then my restriction is that x has to be bigger than 0. And that just makes it so that, because I'm fixing to go into log world, okay? That's what I'm trying to say. Now, I can take this derivative all day long. But again, we saw a while ago that it's easier sometimes if we go into log world. So whatever I do, as long as I do it to both sides to maintain equality, I can do it to both sides. So look at this magic. If I take this derivative, if I take the natural log on both sides, okay, so why do I want to do that? Because that's going to make me be in a position where I can simplify this side. So it's easier to differentiate. So I'm also trying to find dy dx. Okay, so we're going to introduce the dy's. We're going to introduce the dx's again. So what is the derivative of a natural log? So the derivative of the natural log of y is going to be 1 over y. Okay, and then I say dy because I took the derivative of y. Well, this one I can separate out. So that's actually the natural log of x plus 1/2 times the natural log of x squared plus 19. Okay, and that's why we're using logarithmic differentiation, because I can rewrite this mess, this argument, and separate it out this way. So now what's the derivative of the natural log of x? It is 1 over x dx. And then what's the derivative of 1/2 times the natural log of x squared plus 19? It's plus 1/2. And then the derivative of x squared plus 19 is 2x over x squared plus 19 dx. So this 2 and this 1/2 are gone. I cannot put these together because they're not like terms. And so I'm going to factor out a dx. So I've got 1 over y dy equals 1 over x plus x over x squared plus 19 dx. Okay, well, I want to solve for dy dx. So I'm going to divide both sides by dx. And then I'm going to multiply both sides by y. So that gives me 1 over x plus x over x squared plus 19 times y. Okay, so everything is fine and dandy. I know what dy dx is, but now you're in two different variables. So what do? Well, do you know what y is? You do know what y is, because y is x times the square root of x squared plus 19. So this is going to go away. So now I know that dy dx equals 1 over x plus x over x squared plus 19 times x times the square root of x squared plus 19. Okay, so basically this is a different format than if I had just left it and not done logarithms. It'll look different, but it's an equivalent answer. All right, so let's try it again. We have, what do we have? We have y equals the square root of x squared minus 49 over x squared plus 49. And I want to take a derivative. So again, this is nasty. This is going to require chain rule, quotient rule, all this kind of mess. So if we go into log world, I'll be able to separate this thing out. So first of all, I'm going to have the natural log of y equals, and I'm going to go ahead, this square root belongs to everything I do. So I'm going to separate this out. I've got a 1/2 times the natural log of x squared minus 49 minus 1/2 times the natural log of x squared plus 49. So the 1/2 belongs to both terms. If it's connected by division on the inside, it's subtraction on the outside. So I just kind of skipped a couple steps. All right, take a derivative. So the derivative of a natural log is the derivative of the argument over the argument itself. I'm going to go ahead and pull my 1/2 out front just so it's not, so it's out of my way. So this is 1/2, and then I've got, what's the derivative? I've got a 2x over x squared minus 49 minus, and then I'm going to have, you know what, just so it's easier to see, I'm just going to do it this way. All right, so 1/2, here, there you go. All right, and then this derivative is 2x over x squared plus 49. So why did I change my mind in the middle? Because this 1/2 and this 2 and this 1/2 and this 2 all reduce out, okay? And you took the derivative of x, so all of this side has a dx on it. So this term would have a dx, this term would have a dx. I just factored it out at the end. So cleaning this thing up, I've got a 1 over y dy equals, and then I have x over x squared minus 49 minus x over x squared plus 49 dx. Okay, so I just rewrote, just to make it a little bit cleaner. All right, divide both sides by dx, multiply both sides by y. So now I've got dy dx equals x over x squared minus 49 minus x over x squared plus 49 times y. Except for I don't want to have two different variables on the right. And so do I know what y is? I do. It's right here. And so instead of writing a y right there, I'm going to substitute this in for it. So that means this is times the square root of x squared minus 49 over x squared plus 49. And that's your answer. So this is multiplication. All right, 2 more, I think. Maybe 3. 2 more. And then we're done with this section. So again, I've got y equals, I keep staring at my pen because the tip of it's broken. All right, I don't think you care, but whatever. All right, so x plus 1, x minus 6. Over, and then I've got x minus 1, x plus 6. And I want to take a derivative using logarithmic differentiation. So again, I could FOIL all this out on top, FOIL all this out on the bottom, and then just use quotient rule, go from there. I could use product rule on the top, use quotient rule as the bigger thing, use substitution, whatever. But we're practicing logarithmic, so we're going to do logarithmic. So take a log of both sides. So I've got the natural log of y equals, And now I'm going to go ahead and separate all this mess out. So I've got the natural log of x plus 1 plus the natural log of x minus 6 minus, because I dropped to the bottom, natural log of x minus 1 minus the natural log of x plus 6. Sorry, I ran out of room. All right, so take a derivative. The derivative of a natural log is 1 over, or the derivative of the argument over the argument itself. So then I get, remember, each one of these is going to have a dx. So I'm just going to factor it out at the end. So this will become the derivative of the argument over the argument itself plus the derivative of the argument over the argument itself minus the derivative of the argument over the argument itself minus the derivative of the argument over the argument itself. And everything has a dx, so I just factored it out at the end. So divide both sides by dx, multiply both sides by y. So I get dy dx equals 1 over x plus 1 plus 1 over x minus 6 minus 1 over x minus 1 minus 1 over x plus 6. But I multiplied by y. And so I'm just going to put what y actually is, which is x plus 1, x minus 6 over x minus 1, x plus 6. And so that is your derivative. That is the formula for slope for any single point on the curve. All right, so the last one, we're going to use implicit differentiation. So remember, we're going to use implicit if my function is not a function. If you're not dealing with a function. Or you've got multiple variables. So I got plus 4y equals 25. Hang on, it's a 4x. Not that you know that, but it's a 4. Trash. All right, the natural log of x times y plus 4x equals 25. All right, so remember, implicit differentiation just means that instead of getting this as a function format where y equals everything else, I'm just going to take everything in terms of its own variable. So first of all, this is connected by multiplication. So I'm going to separate this out using addition equals 25. And now just dive in and start taking derivatives. So what's the derivative of a natural log? It's the derivative of the argument over the argument itself. And you took a derivative of x. So note that with a dx. Plus the derivative of y is 1 over y. Sorry, the derivative of the natural log of y is 1 over y dy, plus the derivative of 4x is 4 dx, because you took the derivative of x, equals 0. If it's got a dx, I need it on the right, and so this is going to get subtracted over, and that's going to get subtracted over. So I've got a 1 over y dy equals a negative 1 over x minus 4 dx. Okay, and now I'm going to flip-flop back. So I've got dy dx equals negative 1 over x minus 4, and then multiply both sides by y. So that becomes a y. Now go back up here. I don't know what y is, but I was working with two variables to begin with, and so I'm going to end with two variables at the end. So don't worry about substituting in for y on that one. And that is the end of 5.1.